Hi, we're going to pick up from where we left off in the last video, and we were talking about taking functions that we want to assess the limit at a particular value, but when I try to substitute in that value into the function, we're getting something like 0 in the denominator, and that would say that it's not in the original function's domain. So at that point, we tried factoring it to see if we could cancel out common factors and come up with an equivalent form as far as the numerical analysis would be for the limit. And it looks virtually the same on the graphs, except one of them has a hole at that point and the other one doesn't. So let's pick up where I left off with that square root problem. And this is the limit as x approaches 2 of the square root of x minus the square root of 2 over x minus 2. Now this one has square roots in the numerator. In your past, there were rules all through beginning algebra and intermediate algebra and college algebra and even trig that you could not have radicals in the denominator, but radicals in the numerator were okay, and they still are okay. But we're trying to evaluate this limit at 2, and when you substitute 2 in, let's start with the denominator, you would get 0 in the denominator. So that says that 2 is not in this function's domain. Actually, you would get 0 in the numerator as well, and that gives you 0 over 0, which is an indeterminate form. We'll talk about that in a later video. So you could actually handle this problem in a later version. I don't actually think you'd prefer the later version over what we're going to do now, but everybody's different. But if you have a tutor and they're starting to talk to you about L'Hopital's rule at this point for indeterminate forms, I'm not sure your teacher will accept that approach at this point because the technique they use, you don't know yet. And you probably won't know if you have a test just over limits. So we're going to use this technique, which is algebra based, and it goes kind of like this. All right. We have nothing to lose except that blank is definitely wrong. So you look at this problem and you think, well, I can't just leave it blank. I can't substitute the 2 in. I can't use L'Hopital's rule. So at least let's we don't have anything to lose. Let's try to rationalize the numerator, and at least the little space on your test isn't blank. Maybe they'll give you some partial credit. And I hate to say it, but a lot of times that's what you need to be thinking. I got to try something, so blank is definitely wrong. So what we're going to do is multiply this to try, just for lack of anything else, as if it was an algebra problem. And if we multiply it by its conjugate, we would definitely change the numerator. I'm not sure it's going to benefit me in the denominator yet, but blank is wrong. So remember that when you are trying to rationalize square roots, if you had 2 terms, they didn't both have to be square roots, but if you have 2 terms and one of them is a square root, you multiply it by its conjugate, which is the same binomial, same items in the binomial, but the sign in the middle is different. So we're going to clean this up, and until you actually substitute in that 2, you have to keep writing the word limit. I don't know a teacher that will let you stop doing that and still give you full credit, but who knows. Now, this x minus 2 right here is the binomial that gave us pause as to what to do, because that's the one that gave us 0 in the denominator. It is not usually to your advantage to multiply that binomial times the binomial over here, because you're wanting, with, hopefully, to make this go away. So we have kind of like we did when we factored, we're hoping it cleans up somehow. So we're just going to write our pieces down, and we'll see later if we need to multiply it out. you can always do that later. Now, these up here, we're going to actually multiply out using the FOIL method. And I'm going to show you all the steps once, just to remind you in case you've forgotten. But you don't usually have to put this step in unless you just want to. So the square root of x times the square root of x is the square root of x squared, because remember you multiply the insides. The square root of x times the positive square root of 2 is a positive square root of 2x. And then because they're conjugates, minus square root of 2 times x is minus square root of 2x. And minus square root of 2 times a positive square root of 2 is a minus square root of 4. So let's see where we're at. So the square root of, let me do my limit again before I forget, and you'll learn to get this written down before you start doing any of the math. So the square root of x squared is x. This plus square root of 2x and minus square root of 2x goes away. That's what happens when you have conjugates. These two go fall out to 0. And the square root of 4 is 2 over x minus 2, square root of x plus square root of 2. Now, here we go. This x minus 2 cancels this x minus 2. And as I'm sure you remember, when you cancel out everything that's on one side of the fraction, there's still an understood 1. And so here is where we're at. So see how we've changed it into an alternate form. So my idea of, well, I don't have anything to lose, turned out to be the right idea. Now, if I put the 2 in where x is, I don't get 0 in the denominator. So I have 1 over the square root of 2 plus the square root of 2, which is 1 over 2 square roots of 2. Now, let's talk about this for just a second. When you get to calculus, you've spent years, with people saying, you can't leave a radical in the bottom of the fraction. You can't leave a radical in the bottom of the fraction. You can't leave a radical in the bottom of the fraction. And then you get to calculus and they go, oh, that's okay. We know that you know how to fix it if you need to. It's okay to leave it. Now, some of your teachers will be okay if you leave it like this. And I'm one of those that would let you leave it like this. However, if you do the next step, I'm one of those that gives you extra credit. But you need to find out what your teacher wants. Some of them would take off if you leave it here. Some of them give you credit more if you go past that. So let's go the extra step and see what that looks like. And then you need to find out what your teacher wants. So if you go back to the old algebra rules, which is, I can't leave a radical in the bottom of the fraction. This is not a binomial. This is not 2 terms. This is 2 times the square root of 2. Plus and minus makes space for multiple terms. Multiplication does not. So this is 1 term. So you would multiply it by itself to get the square root of a square. And you would have the square root of 2 over 2 times the square root of 4, which is 2. And 2 times 2 is 4. And so one of these two, the limit as x approaches 2 of the square root of x minus the square root of 2 over x minus 2, either this one or this one, will be acceptable to your teacher. And part of being a good student is you have to learn what your teacher's format is. It's like your English professor. Every English professor has their things that they like to have, and other English teachers could care less. So you have to figure out what your math teacher wants. Now I just want to show you, I'll kind of blow this up where you can see it. This is those Desmos graphs again. This first graph is the original function typed in. This second graph is the one that we transformed it into, the square root of x plus the square root of 2, this one right here. And you'll see that the graphs look the same, all right? But this one, if you could blow it up and look at it really big, would have a hole right there at 2. Let's keep moving on. All right, but let's not keep doing that. Okay, where I show you the 2 graphs. Let's do another one. let's look at the limit as x approaches 3 of the square root of x plus 1 minus 2 over x minus 3. Now, this one's a little bit more complicated as far as the square root goes. It has an x plus 1 in it. But let's not get hung up on that. Let's just look at it as in, I have a function at which there is a square root in it somewhere, and I cannot substitute the number that they're wanting me to evaluate in right here because I would get 0 in the denominator. I'm not going to look at the numerator right now because I'm not doing indeterminate forms. So I'm going to try my technique again of multiplying it by the conjugate. Okay. And then we're going to clean this up and see what happens. Just remember that it's this x minus 3 that gave us 0 in the denominator. Let's not multiply it out using the FOIL method because I'm hoping I can cancel it out. So let's not do unnecessary work that we have to undo. Now, if I multiply the two tops together, I can use the FOIL method. So the square root of x plus 1 times the square root of x plus 1 is the square root of x plus 1 squared, which is x plus 1, right? It's the square root of x plus 1 squared. Okay, or you think of it as x plus 1 squared. Either way, right? So that's that first term. Right, you don't really need parentheses, but I'm just trying to help you see it. Square root of x plus 1 times 2 is 2. Square root of x plus 1 minus 2 square root of x plus 1. And minus 2 times 2 is minus 4. And like we expect, those go to 0. I probably won't show you that step next time. Right, so now I've got x plus 1 minus 4. So that would be x minus 3. And this is about when you think, oh my goodness, this is going to work out really nicely. You have to start before you're positive that that's the technique you are supposed to use. You have to start and try it. And then right before you finish, you're like, okay, that was a good choice. But you don't know it to get started necessarily unless you've worked a lot of these problems for practice. So it's the limit as x goes to 3 of 1 over square root of x plus 1 plus 2. And if I substitute the 3 in, that's not going to give me 0. So I'm going to go ahead and do that. And I would have 1 over the square root of 4 plus 2. Square root of 4 is 2. So this is 1/4. Now, you don't have to do all of these steps for your teacher. Some of them you may want to do them all. Some of you may want to skip. Just be sure that your teacher can follow along with your logic, because if they have to guess what it is that you did, especially if you were wrong, it's a lot more partial credit off normally because they don't know what you did. If they can clearly see what you did, it may be less partial credit off because they could follow you along and thought, well, that may not have been the best choice, but I can see why they thought that. And so instead of maybe being 2 points off, it might be 1 point off. So please show your teacher enough work to have them be able to follow along with you. So let's try this one. Let's do the limit as x goes to 0 of the square root of x squared plus 9 minus 3 over x squared And I'm going to use the same technique I have before, which is the square root of x squared plus 9 plus 3, which is its conjugate, over the square root of x squared plus 9 plus 3. So when I multiply that out, and remember you have to keep writing the word limit until you substitute the number in. On the bottom, in the denominator, you would have x squared times the square root of x squared plus 9 plus 3. And on the top, you'd have the square root of x squared plus 9 times the square root of x squared plus 9, which is x squared plus 9. And then you would have plus 3 times the square root of x squared plus 9 minus 3 times the square root of x squared plus 9. I didn't really realize that was going to be a tongue twister, but I think it has. And minus 3 times plus 3 is minus 9. All right. If you can't laugh at math and have a bit of a giggle or a chuckle or something like that, math can be become very tiresome and maybe intimidating, kind of scary. But try to have a little fun with it. If you can't poke fun at math, there's not much you can poke fun at, because you can enjoy it, really. I know some of y'all are rolling your eyes like, yeah, sure. Okay, now, so here we go. This x squared cancels this x squared, and you have the limit as x goes to 0 of 1 over the square root of x squared plus 9 plus 3. And about right in here, you get to smile and congratulate yourself for, okay, this is going to work out. So if I substitute 0 in there, because it looks like that should work, I'd have 1 over the square root of 0 squared, which is still 0, plus 9 plus 3. So you have 1 over the square root of 9, which is 3, plus 3, which is 1/6. So we need a nice proper sentence. Square root as x goes to 0 of the square root of x squared plus 9 minus 3 over x squared. My engineering teachers used to make you use a template to get a nice square, or a good ruler if you had a good eye. So they would not like these, but Okay, we're freehanding it. Now this last problem I want to show you kind of a way to reason your way through a problem. So just bear with me here for a second, and let's talk about the limit as x approaches 4 of the square root of 5 minus x minus 1 over 2 minus the square root of x. Right. Now, we're going to actually end up using two techniques and kind of comparing them. But what I really want you to do is, when we get into the middle of this, I want you to listen to what I'm saying, because what I'm saying is what you have to think to work your way through what's going to turn out to be a false start, and then you have to back up and try something else. But I'm going to try to verbalize what it is that I'm thinking, so that you can have more confidence in your own thought processes when you kind of run into a brick wall and have to back up and try again. All right. So we look at this and we go, great, there's 2 square roots. Can't put 4 in the bottom and not get 0. So let's fall back to algebra and let's try rationalizing the denominator. So we would have 2 minus the square root of x, plus 2 plus the square root of x. I'm thinking ahead to what I want to do next instead of being present in this moment. Equals. All right, so I always write my limit down before I worry about what's going on. Now, the top is kind of a mess, right? So I want to hold off on that for a second because, like usual, we're kind of hoping the numerator, the denominator, does something where it's not 0 anymore. So 5 minus x minus 1 times 2 plus the square root of x. So I'm just going to hold off on that for a second. I want to look at the denominator. So when you look at the denominator and you multiply this out, you go 2 times 2 is 4. Okay. Plus 2 square root of x. Because this is a complicated problem, I'm going to write this all out. Minus 2 square root of x. And minus the square root of x times the square root of x is the square root of x squared, which is x. So this denominator right here is 4 minus x. And before we go any farther, I just want you to look at it. If you look at it, we still cannot substitute the 4 in directly because I'm still getting 0 in the denominator from my new version of the original function. So that doesn't look like that's going to work too well. So let's back up, keep up with that thought of blank is definitely wrong. But what I want you to concentrate on as we move forward is this multiplication right here. The multiplication at 2 minus the square root of x times 2 plus the square root of x yielded us 4 minus x. Okay? So I want you to keep that kind of in the back of your head, and we're going to start this problem over. And we have the limit as x approaches 4 of the square root of 5 minus x minus 1 over 2 minus the square root of x. Right? So it's same problem that we had. Okay, and what we're going to do is, since we kind of ran into this brick wall with rationalizing the denominator, let's try rationalizing the numerator. Okay, so we go, all right, I don't know that this is going to be any better, but let's give it a try. All right. Now again, it's this term right here that's causing me to get 0 down there. So let's leave it as it is in hopes that it will go away. And let's multiply out the numerator. So the square root of 5 minus x times the square root of 5 minus x is the square root of 5 minus x squared, which is 5 minus x because the square and the square root cancel. Okay, this is plus square root of 5 minus x minus the square root of 5 minus x, and minus 1 times plus 1 is minus 1. Okay, you all right so far? All right. So we have the limit as x approaches 4 of, let's see, 5 minus 1 is 4 minus x over 2 minus the square root of x, square root of 5 minus x plus 1. And you look at that and go, well, hey, I'm running into this brick wall on this one too. And then you think, nope. Look back over here. See this 2 minus the square root of x, which is like this one. All right, but see this 4 minus x? This 4 minus x right here actually factors down to 2 minus the square root of x times 2 plus the square root of x. So I'm not going to multiply the numerator by anything. I'm going to factor it. Just like when you had something like 4 minus x squared and you said it's the difference of 2 squares. Okay, I'm not going to multiply it. I'm going to factor it. So 4 minus x from our previous attempt. What? Here we go. Let's try this again. The limit as x approaches 4. So 4 minus x, I'm going to factor that down, and it's 2 plus the square root of x times 2 minus the square root of x. Those are its factors. We're not multiplying it by anything. We're factoring it over 2 minus the square root of x. Square root of 5 minus x plus 1. And this one cancels this one. And you have 2 plus the square root of x over the square root of 5 minus x plus 1. So let's see how that works. So we would have 2 plus the square root of 4 over the square root of 5 minus 4 plus 1. So this is 2 plus 2 is 4. And the square root of 5 minus 4 is the square root of 1, which is 1 plus 1 is 2. So this turns out to be 2. So the limit, we need a good ending complete sentence. Your teacher will smile. Or at least not take off. Because some of them will take off if you don't leave a full sentence with a lovely boxed answer. That would be like me. Okay, now I wanted to show you this problem because I want you to know that not everything is straightforward. Sometimes you try something and you can't get past a certain point, so you try something again. But when you try something and you can't get past a certain point, kind of pay attention to it and just sort of file it away for future reference sometime. It may save you from running into that same problem next time. It may save you from making an attempt like that doesn't work, but it may also have a lovely little piece of information in it that you could use going forward as you attempt it again. So look it over. Don't just get angry with it and scratch it out and move on. Look it over and kind of look for things, maybe see if you did something wrong and that's why you hit a brick wall. But try to see if there's any information that you can use to move forward. Now, this is going to be the end of the lecture. Do note that in the description underneath this video, there will be links to the previous video in the series, the next video in the series, but there's also a link to a practice problems worksheet where you can practice some of these problems. When we get to the end of all of these different individual limit techniques, I'll put in a video that's like all of them mixed up together so that you can see. Because what we're developing is a set of tools. If it looks like this, we're going to do that. If it looks like this, we're going to do that. Like when you look at a project, you don't use a hammer all the time. Sometimes you need a screwdriver. Sometimes you need a hammer. Sometimes you need a chisel. Sometimes you need a saw. So when you're doing problems, you look at the problem that's been handed to you and you look at what its appearance is and then take your best guess as to what the technique is. So after we get through all of these, we're going to build, or I'll show you what my list looks like. And it starts off this way. It starts off with, oh, they want me to take the limit. Can I substitute the number straight in and get an answer that's not 0 in the denominator or something? That's my first bet. Can I please substitute it in? Okay, if that doesn't work, my second try is going to be, can I factor it and try to cancel out whatever's giving me the problem in the denominator? Factoring is one of the things that I'm good at, so I will always try that next. Well, if that doesn't work and it has square roots in it, let's try multiplying it by its conjugate and see what that is. And then the next video we're going to talk about is what if it's complex fractions. So the next video will be the limits of rational functions that are complex fractions, where you would have fractions inside of a fraction. So in the description, there's links to the next video, past video, and to a problem set for you to try this technique. And bye for now.